Hello everyone. In this video, let's discuss how to write a program to find the count of prime numbers. Given an integer n, return the number of prime numbers that are strictly less than n. Example 1, n equal to 10. So from 1 to 10, I need to find totally how many prime numbers are there. The output is 4, which is there are 4 prime numbers. The 4 prime numbers are 2, 3, 5 and 7. If n is equal to 0, the output should be 0 because there is no prime number. If n is equal to 1, the output should be 0 because 1 is neither prime and nor composite. Okay. Now let's discuss the logic of this program. This program can be solved in 3 different approaches. So I'll take the first approach. I'll be starting the iteration from I equal to 1 and then I less than or equal to n I plus plus, and inside this I'll be checking whether a number is prime or not. So to check whether a number is prime or not, we can say if a number is divisible by 1 and the same number, I can say it is a prime number, else it is not a prime number. So for that I will be taking one more for loop, j equal to 1, j less than or equal to I and j plus plus. So here what I will be doing, I will be starting the iteration from 1 up to I will be iterating because I am going to check whether the I value is a prime number or not. So the number 1 and the same number, if it is divisible by 2 numbers, I can say that it is a prime number. In this case, the time complexity of the program will be n and then n into n, which is big O of n square. So the logic which I am choosing is, I will be starting the iteration from 1 up to that number I will be iterating. If we have exactly 2 divisors or if we have exactly 2 factors, I can say that it is a prime number. So this will take a time complexity of n square. Here we have one more logic where it can be solved in big O of n into square root of n. Why? Because here the iteration starts from 1 to I. So instead of iterating from 1 to I can start the iteration from 2 and I can end the iteration up to square root of I. Why? Because prime numbers are number which are divisible by 1 and the same number. So in the range, I am not considering 1 and I am not considering the same number. In this case, if the number is getting divisible by any of the number, I can say that it is not a prime number. The number is not getting divisible by any number, that number can be said as a prime number. That is one more logic where the time complexity will be square root of n, which is n into square root of n. We have one more approach where that will take a time complexity of big O of n into log of log n. So this is the efficient approach. The name of this algorithm to solve this with n into log of log n is nothing but Sieve of Eratosthenes. So this is one algorithm which helps us to solve prime numbers in a range with a time complexity of n into log of log n. And here we have to observe one thing: whenever you are trying to reduce your time complexity, space complexity get increased. In these two cases, the space complexity will be 1 because we have not taken any extra space. In this case, we have a space complexity of n because we are trying to reduce the time complexity. Space complexity obviously get increased. Now let's discuss the logic of this algorithm to find prime numbers in a range. So let me take the value of n is equal to 30. So here what I am doing is, I am going to take an array size of n plus 1 and I am going to initialize all the values as false. So here I have taken array of size n plus 1, that is 30 plus 1 31. I have initialized all the values as false. Fine. And I am going to start the iteration from the value 2. Why am I starting the iteration from the value 2 is, 2 is the first prime number we have. Okay. So I will be checking whether the value which is present on that index is false or not. If the value present on that particular index is false, I will make all the multiples of that particular index value as true. So what are all the multiples of 2? 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Fine. I'll go for the next iteration. When I go for the next iteration, I've got the value called 3. Check what is the value I have in that particular index? False. If it is false, I should make all the multiples of 3 as false. That is 6, okay, 9, 12 is already false, 15, 18 is already false, 21, 24 is already false, 27, 30 is already false. Then go for the next iteration. Now I will be going for the value called 4. Check whether the value is false. No, it is true. If it is true, I don't want to do anything. Go for the next iteration. Okay. 5. So when I go for 5, what should I do? Check whether the value is false. Yes, the value is equal to false. If the value is equal to false, what should I do? I have to go for all the multiples of 5 and I should make it as true. 10, it is already true. 15 is already true. 20 is already true. 25, I'll make it as true, and 30 is already true. Now I have to go for the next value. So like this, how many iterations I should go for? That is very simple. Up to square root of n. What is square root of n? 5. So up to 5 iterations I can go. That's all, the logic got over. Now after coming outside the for loop, what I have to do is go for the iteration. Start the iteration from 2 because 2 is the first prime number we have. From 2 to 30 we have to iterate. Wherever the value is false, those numbers are prime numbers. See here, 2 false, 3 false, 5 false, 7, 11, 13, 17, 19, 23, 29. So wherever the value is false, those numbers are prime numbers. This is the logic of the program to find prime numbers in a given range in an efficient approach. Here, if you want, you can make the index value 0 and 1. You can initialize the value at the beginning as false. Because we know 0 and 1 is not a prime number, in the beginning itself we can initialize it as false. Hope you are clear with the logic. Now let's try to implement it as a program. So here first we have to declare an array of size n plus 1. So here I am going to give the type as boolean because we are going to store true or false in the particular array. So I will be taking an array of type boolean arr is equal to new boolean n plus 1. So here by default the value false will be stored in the array because the default value of boolean is false. Fine. Here what I am going to do, I am going to start the iteration from 2. So int I equal to 2, I less than square root of n, okay, I plus plus. I told the iterations should start from 2 and I should end at square root of n. I don't want to check for all the numbers. Okay. What should I do now? If that particular index value is having the value as false, if arr of I. So arr of I is false. If I give not, the condition becomes true. So if I have the value as false, what should I do? I should make all the multiples. Make all the multiples as true. So for that I am going to take a for loop. Int j is equal to I into I. So if it is 2, 2 into 2, 4. I will start from 4 onwards. J less than or equal to n. J equal to j plus I. Because I should make all the multiples as true. So for that arr of j is equal to true. I will initialize all the value as true. That's all. Now I will go for next iteration. If it is false, make all the multiples as true. Go for next iteration. If it is false, make all the multiples as true. Go for next iteration. If it is true, ignore it. I will come out of it. So like this, I have to complete the process. Once it is done, start the iteration from 2 onwards. I less than n, I plus plus. Now I have to check whether it is a prime number or not. How can I know? If it is containing the value as false, it is a prime number. So I am going to count the number of primes, right? So further I will be taking variable count. I will initialize the value as 0. So here what I am going to do, if it is having the value as false. So if not of arr of I. Arr of I, that will give true. Not of arr of I, it is having the value as false. So if that is having a value as false, I will go inside, I will increment my count value. That's all. Finally, I will return the count. So here what am I doing? Checking whether the array value is false. If it is false, increment the value. That's all. Let's run the code now. Okay, there is an error on line number 2. Sorry, line number 7. Okay, square root method. So here I should give it as math.square root because it is Java, right? That is why it was showing an error. Okay, it passes test case. if you are finding it difficult, you can use this particular line in another term. So I'll just comment and I'll show you. Above I'll write. This can be written in another way. The alternate way to write this is for int I equal to 2, I into I less than n. I plus plus. This is another way where we can write. So I into y. So that is I square. So if I square value is less than n, these both are same. That's all. Let's submit the, it passes the test cases. Let's submit the code now. As it passes all the test cases. That's all.